This video contains examples of using a spreadsheet program to perform Dix equation and time-to-depth computations. These examples start from time-velocity pairs, as typically obtained during velocity analysis, VLANs. This video is not an examination of the theory and approximations of Dix or time-depth conversions. This video concentrates on how to use the spreadsheet program.
In preparation for this video, you might want to watch my videos about VLANs and mutants, bilinear interpolation, and velocity smoothing. Extensive examples and tests for these programs exist in the demos directories. These programs are typically used to derive, interpolate, smooth, and apply stacking velocities. This video shows how to use a spreadsheet program, LibreOffice Calc, for Dix equation, time-to-depth, or similar computations. The intention is to demonstrate how you can use the spreadsheet program. Everything in this video should be considered an approximation. Whether computations herein are suitable for your data is your decision. I believe the major uses of Seismic Unix are as a learning tool or for small one-person situations where you are doing the seismic data processing. As part of that concept, I wanted you to be able to use spreadsheet programs to perform manipulations and computations on velocities, mutes, or statics. To that end, I defined CSV Q files. In particular, this video shows example uses of varying tuples Q files. A varying tuples Q file is what is needed to contain time-velocity pairs where the amount of pairs is different at different locations. In other words, a typical velocity picking situation, VLANs. After running the VLAN script in demos geom3d subin big CSV, you get values such as these in the stackval.p1 file. You can use the stackval.p1 file in sunom CSV, of course, but you can also use it in subinqcsv as shown below. Note you can also add more values here, tstat, floating datum static values. But most importantly, note the i=2 option. This outputs a varying tuples Q file from the input parameters. Option i=2 added to subinqcsv May 2024. Before continuing, I want to make it clear that you can also specify the same parameter values directly into the subinqcsv setup. No need to use a stackval.p1 file. The output varying tuples Q file looks like this. Many values are automatically output if a 3D grid definition is input. Note that each Q record contains all the values for one CDP location. And note the Q records can contain different amounts of time velocity pairs. You can do the same for 2D. Just do not input a 3D grid. The output Q file looks like this. So now you can produce a varying tuples Q file with time velocity pairs. That was all just preliminary to the main point of this video. These Q files can be input into spreadsheet programs such as LibreOffice Calc, and spreadsheet programs can perform all kinds of computations, including Dix equation and time-to-depth computations. Next, I demonstrate how using the simplest ways I know. First, input the Q file. Since it is a CSV file, you see this. Use options separated by and comma. Next, you'll see this. The first 5 rows here do not mean anything to calc, but you should retain them if you want to use the output later in Seismic Unix. Spreadsheet programs like LibreOffice Calc have all sorts of options. I am not an expert in calc, so I'm just going to show how I proceed. First, change the name of this sheet to VNMO by left double click. Next, right click the VNMO name once, copy it to end, and give it new name Vint. Then select all the Q rows and delete them. That leaves just the top 5 rows. Select the cell in column A, row 6 by clicking on it. Then type equal vnmo.a6. Notice that equal vnmo.a6 appears in 2 places. You can put the cursor in either place to continue typing. Now hit enter. Notice that cell A6 now contains Q. That value was copied from sheet VNMO, cell A6. Now select cell A6 again and also option copy. Then select cells B6 to J6 and also option paste. This results in copying the corresponding values from the NMO sheet. Click cell B6 and you see equal vnmo.b6. Remember, we copied cell A6 into cell B6, but calc automatically changed the equation during the copy. This also occurred during the copy of the other cells, such as cell H6, where you can see equal vnmo.h6. Now, type the Dix equation into cell L6. A close-up looks like this, which in mathematical notation is, and produces the Dix interval velocity values for layer n. Note that time velocity pairs means velocities and times need to be separated by 2 letters when this equation is specified. But, of course, you only need to specify it correctly in one cell, since calc copy-paste will adjust it for every other place you use it. So, copy-paste cells K6 and L6 to more columns on the end of row 6, which results in these values. Remember, these values are being computed from the VNMO sheet values. Note the values in columns S and T, which occur because there are not enough time velocity pairs in row 6 of the VNMO sheet, but ignore them for now. Now, select row 6 and copy it to row 7. Calc's copy-paste now also changes the equation row numbers from 6 to 7. Now, copy-paste everything from row 6 to rows 7 to 20. Note there are bad results where no pairs exist in the VNMO sheet. You can just select those cells and delete their values. Calc has functions such as if and if blank if you want to get automatic handling of this situation. But that makes the cell equations more complicated. You should also change these names from VNMO to Vint to avoid confusion. That concludes the Dix equation part of this video. If you use Save as Type CSV, only the values on the active sheet are output. The output Q file can be input to subinqcsv, and interpolate it in space and time. But now that we have a spreadsheet containing interval velocities, we can compute depths as demonstrated next. Copy sheet vint and name it depth. Note that during the copy, the cell equations changed from VNMO to vint. Note the value in cell L8 is changed because its equation is using values from sheet vint, which have already been computed from sheet VNMO. Just reset the equation in cell L8 to copy the value from sheet vint. To compute thickness, set K6 equation equal bracket vint.m6 minus vint.k6 close bracket divide 2000 multiply vint.l6. Divide by 2000 since the time needed is one-way time in seconds. Now copy the K6 and L6 pair to the pairs from M6 to T6. Then copy row 6 to row 7 to 17. And note again, there are bad results on the ends of the records. Just delete them. But of course, the computed values in columns K, M, O, and Q are thicknesses. To compute depths, add K6 to the equation already in cell M6. Then copy M6 to O6 and Q6, and then copy row 6 to all rows. This results in summing all previous thicknesses on each row. Naturally, some values need to be deleted again. The computations done here result in depth at bottom of interval. So the last velocity has no depth value. It is a good idea to also change these names to depth. Or you can keep all the Dix computations within one sheet. There is nothing that prevents you from computing the vint values within one sheet. Restarting from just the VNMO sheet, add another column to every time velocity pair. Then put the Dix equation computation in these new columns. You can also add a fourth column into the tuples and compute the depths. A benefit of keeping these computations inside one sheet is that you do not need to specify the sheet name in equations. No need to type vnmo.k6, just K6. I conclude this video by including the Q file standards next. My official Q file standards file exists in the demos geom3d subinqcsv.